Testing and profiling. Why are tests important? What we have been doing so far is somewhat similar to driving without seatbelts on. It's working when it's working, but when it doesn't, things can become ugly pretty quickly. So let's put our seatbelts on and let's talk about testing. The integral part of writing any code is making sure that it produces valid output and does not crash. We have done this partially when we were checking the results of our API calls. It worked well, and these were the so-called end-to-end tests. We started the server, gave it an input, and were expecting a result. We tested the whole program as if it were a black box. This might work for smaller applications, but for any serious project with multiple moving parts, it is too time-consuming, and locating an error might prove to be a challenge. We need to be more granular in our testing and write the so-called unit tests. Unit tests focus on the smallest units of code. Usually, this means individual functions. They not only test the input and the output, but also should check for expected state changes if such occurs. This means that if we change the internals of a given function, the output still can be consumed by other functions. Meaningful and comprehensive unit tests are helpful in locating errors while coding instead of during later stages. An additional value of unit tests is that sometimes they can also provide good usage examples for other developers. I mentioned the words meaningful and comprehensive. What exactly do they mean in this context? A meaningful test is a test that does not just run over a particular piece of code, but actually tests it against both valid and invalid input, including edge cases. It's not enough to make sure that the code works, we also need to know when it breaks. This makes our code safer. We don't want an unexpected error to stop the execution of the program, and we want to make sure the invalid results are also properly returned, so that any further error handling is not disrupted by an invalid call returning supposedly valid, though incorrect result. Such a test also ensures that the expected state changes were made, and items were duplicated and not just assigned, and so on. As for comprehensive, it means that all pathways are explored. One metric that is supposed to measure this is code coverage. Code coverage is calculated during unit test execution and describes what percentage of code was traversed. The code coverage metrics can sometimes be misleading. Consider function A that invokes function B during its execution. If we write a test for function A, we are also by extension covering some use cases for function B, and from an algorithm perspective, it might seem that we did test function B as well. However, there might be some cases of function B that are not covered by the function A unit tests. If we blindly rely on code coverage as a metric, we might miss the whole purpose of writing the unit tests. Code coverage is good, but it's more important that the tests are meaningful and comprehensive. That said, we should always strive for 100% code coverage. However, in many cases, the goal of 80 to 90% is much easier to attain because some edge cases invoking other functions are left untested. Having said all that, you might see me skip writing unit tests for simple functions in this course. I want to stress that this is solely because we are focused on the API aspect, not on the proper production-ready, test-driven development. In your production code, you should always make sure that your code coverage is as high as possible and your tests are meaningful. I hope, though, that you can forgive me for this do as I say, not as I do statement. If you want to learn more, there are plenty of test-driven development courses that I sincerely recommend you take. This is the general theory of unit tests. Let's now spend a few minutes talking about how they are implemented in Go. It's extremely simple to start writing unit tests in Go. All you have to do is to create a file which name ends with _test, and Go knows that this code should only be included during testing. Here are several other things that you should remember. When you build a binary, such code is not included in the build. Therefore, never put any actual production code into the test files. Test code is local and cannot be shared between two packages. Standard uppercase name rules for exporting do not apply. Functions that perform actual tests must have names that start with test and follow with an uppercase name, for example, test_add_user or test_router. Test function takes as an argument the pointer to the T member of testing package. It is commonly named lowercase t. If you want more information about implementation of unit tests in Go, take a look at the testing package documentation. There's plenty of options there that you can explore.